the American West is not burning as one fire, it is burning as dozens of separate emergencies competing for the same crews, aircraft, and time. And on August 2nd, the National Interagency Fire Center reported 87 uncontained large wildfires across the western geographic areas of the United States. 50 were concentrated in Oregon and Washington alone. And at the national level, the wildfire response system was operating at preparedness level 5, its highest stage. That is the current emergency, but it is not the same as saying every mountain, city, and desert in the West is engulfed in flame. It is also not accurate to call every incident massive. In federal reporting, a large fire can mean 100 acres in timber, 300 acres in grass or brush, or a smaller incident important enough to require a major management team. The corrected number is still extraordinary. 87 uncontained large fires were burning across the Northwest, California, the Northern Rockies, the Great Basin, the Southwest, and the Central Rockies. Together, the active Western incidents covered more than 2.8 million acres in the National Resource Summary. And yet acreage is not the part that makes this moment most dangerous. The real pressure comes from simultaneity. A fire in Washington may need the same type of helicopter requested in Oregon. A new grass fire in Nevada may compete for engines already assigned to Idaho. A wind shift in Montana can force national coordinators to move crews, while another incident is threatening homes near Spokane. The fires are separate on the map, and the response system connects them. Preparedness level 5 means national resources are heavily committed, emergency measures are being used to sustain operations, and even quieter regions are being drawn down to support active ones. It is not an evacuation order for the entire West. It is a warning about how little spare capacity remains when the next ignition occurs. That is why the number matters. For documentaries that follow the physical event and the system behind it, subscribe and stay with us. The largest risk is not that 87 fires somehow merge into one wall of flame. It is that new fires can begin while crews, aircraft, and incident management teams are already stretched across a continent-sized operation. The scale of that operation is visible in the national report. Nearly 28,000 firefighters and support personnel were assigned to active incidents. More than 1,700 engines, over 200 helicopters, and hundreds of crews were committed across the country. The Northwest carried the greatest burden. Its active incident summary listed 52 incidents covering more than 2.1 million acres and supported by more than 18,000 personnel. 24 complex incident management teams were committed in the area. Those teams coordinate strategy, aviation, logistics, communications, public information, medical support, and the movement of thousands of people and machines. A wildfire is not fought by placing one line of firefighters around a perimeter. Large incidents divide the landscape into branches and divisions where crews build and hold fire line while engines protect structures and patrol roads. And aircraft slow the spread where terrain allows, and analysts predict fire movement from weather, fuels, and topography. Logistics sections feed, house, fuel, and communicate with a temporary workforce that can become larger than a small town. When incident demands more resources, those resources must come from somewhere. The Northwest report showed why demand remained high. Fires near communities in Washington were producing wind-driven runs, crowning, and spotting. And some threatened residences, energy infrastructure, railroads, communication systems, or highways. Evacuations and road closures were in effect on multiple incidents. And in the Northern Rockies, the Skillet Fire west of Olney, Montana, was exhibiting extreme behavior with crowning and wind-driven runs while threatening residences and railroad infrastructure. And in the Great Basin, the Big Rock Fire east of Idaho Falls was running through grass and brush, producing long-range spotting and threatening structures. These incidents were not behaving identically. Some fires in the same report were creeping or smoldering. Others were mostly contained. A few had little recent growth. The national count includes a wide range of conditions, and that distinction prevents the title from turning a real crisis into a false claim that every listed fire is a giant advancing front. And what connects the dangerous fires is a physical combination that can appear across many states at once. Dry fuel provides the material. Low humidity removes moisture from grasses, shrubs, needles, and dead wood. Wind supplies oxygen, bends flames into unburned vegetation, and carries embers beyond the fire line, and topography accelerates heat uphill and channels wind through valleys and passes. When those factors align, a fire can move faster than crews can build line around it. The August 2nd predictive discussion described critical conditions across the Northern Rockies, Northern Great Basin, and Northern Plains as a strong cold front moved east and south. In Montana, winds were expected to reach 20 to 30 miles per hour with gusts near 50, while relative humidity fell to between 10 and 20%. Across much of the Great Basin and Central Rockies, gusts were expected to reach 25 to 40 miles per hour as relative humidity dropped as low as 4%. A cold front sounds like relief from heat. For wildfire operations, it can be a dangerous wind machine. The air behind the front may be cooler, but the shifting pressure gradient can accelerate winds and change their direction. A flank that was moving slowly can become the head of the fire. A fire line, built for yesterday's wind, may suddenly face flames from a different angle. This is the ordinary interpretation and the critical exception. Cooler weather can help firefighters. A dry, windy, cold front can make their job worse before it makes anything better. And spotting creates another problem. Burning bark, pine cones, branches, and other embers can rise in a convection column and land beyond the main perimeter. Short-range spotting can cross roads, rivers, and constructed fire line. Long-range spotting can establish new fires far ahead of crews, and the map may show one perimeter. The fire can be operating outside it. That is how containment can be lost without the entire line failing. Containment is the portion of a fire perimeter where control lines are expected to stop further spread under anticipated conditions. It is not the percentage of flame that has been extinguished. A fire listed as 70% contained may still be producing intense behavior along the remaining 30%. A fire at 5% containment may have secure line around one critical community while burning freely into remote terrain elsewhere. Numbers describe the operation. They do not replace the map. The current outbreak grew through more than one ignition pattern. In mid-July, dry thunderstorms crossed Oregon and Washington and produced thousands of lightning strikes. NASA satellites began detecting large numbers of fires in central and eastern Oregon by the following day. Many starts were initially small, and then gusty winds, summer heat, and drought-stressed landscapes allowed some to strengthen. By July 26th, a NASA satellite image showed smoke pouring from dozens of large fires in Oregon and spreading northeast. More than 10,000 firefighters were working in the state, and communities faced evacuation orders as multiple incidents remained only lightly contained. This is how the count can rise abruptly. Lightning does not need to produce one enormous ignition. It can create dozens or hundreds of small starts across remote terrain. Most are contained quickly or go out. A fraction escape initial attack, and several of those may grow at the same time. An initial attack is the first effort to control a fire after it is reported. Local crews respond, engines and aircraft are ordered, and dispatchers try to keep the incident small. When many fires begin during the same lightning episode, the first operational bottleneck may occur before any individual fire becomes famous. There may not be enough aircraft to reach every start immediately. Road access may be limited, smoke may prevent helicopters from flying, and thunderstorms can create erratic outflow winds that reverse fire direction. The incident that escapes during those first hours can become the large fire demanding resources for weeks. A large fire can also create its own local weather. As flames heat the air, the rising column pulls surrounding air toward the fire. And strong convection can increase wind near the perimeter, carry embers higher, and make the direction of spread less predictable. If the column grows tall enough, it can punch through stable layers and produce a towering pyrocumulus cloud. And that cloud is not proof that the fire will become a fire-generated thunderstorm, but it tells crews that heat release has become powerful enough to organize the atmosphere above the incident. And the practical consequences arrive quickly. Aircraft may be unable to make safe drops through turbulent air. Embers can land far beyond visible flame. Firefighters working on ridges or in narrow canyons may lose their planned escape route if wind and slope align. Night does not automatically stop this behavior. Cooler temperatures and rising humidity often help, but dry air, downslope winds, or heavy fuels can keep a fire active after sunset. And in some valleys, inversions trap smoke near the ground and reduce visibility. When the inversion lifts the next morning, fire activity can increase abruptly as oxygen and wind return, and structure protection creates another demand. Engines may be assigned not to attack the main front, but to prepare homes, clear flammable material, identify water sources, and remain in neighborhoods during the passage of the fire. Those engines are then unavailable for another ignition. Aviation works the same way. A large air tanker can slow a moving front by laying retardant ahead of it. But retardant does not extinguish a wildfire by itself. Ground crews must reach the line, connect it to secure terrain, and hold it when flame arrives. And if terrain, smoke, wind, or darkness prevents that follow-up, the drop may buy only temporary time. Wildfire suppression is therefore a chain. Detection leads to dispatch. Dispatch leads to initial attack. An initial attack leads to line construction, aviation support, structure protection, and long-term management. A failure or delay at any link can allow a small start to become a national resource request. And that is why national preparedness is not measured only by acres burning today. Coordinators must protect capacity for tomorrow's fires as well. The National Multi-Agency Coordination Group sets the preparedness level using fire activity, weather, fuel conditions, and the availability of suppression resources. At level 5, national resources are heavily committed. Active geographic areas may need emergency measures to sustain operations, and low-activity areas are reaching drawdown levels. Drawdown does not mean every fire station is empty. It means a region has already released enough specialized resources that sending more could leave it unable to respond if local conditions suddenly change. A hotshot crew, smoke jumper aircraft, large air tanker, helicopter, or management team cannot occupy 2 places at once. Travel takes time. An aircraft require maintenance. Crews need food, fuel, medical support, communications, and safe assignments. The system has depth, but it is not infinite. The 2026 response had already reached beyond the country. Australia and New Zealand sent 74 fire management specialists to support wildfire operations in the Pacific Northwest. The personnel included expertise in aviation, fire line leadership, prevention, mitigation, and emergency communications. Military C-130 aircraft equipped with a modular airborne firefighting system were positioned in Oregon and California to support national operations. These aircraft do not replace the civilian air tanker fleet, and they add surge capacity when the normal system is under exceptional demand. International and military support does not prove the response is failing. It proves the system is using the additional measures designed for its highest preparedness stage. This is the midpoint reframe. The resource ordering system is built to make those connections visible. An incident requests what it needs through a local dispatch center. If the resource is unavailable locally, the request moves to a geographic area coordination center. If that area cannot fill it, the order can rise to the national level. Every step adds distance and time. A crew released in Colorado may need to travel to Idaho. A helicopter may require inspection or maintenance before reassignment. A management team finishing one incident needs a handoff period, transportation, and rest before taking command of another. This is why the number of committed teams matters. A complex incident management team is not a group sent only to the flame front. It is the organizational structure used when an incident exceeds local capacity or involves complicated jurisdiction, logistics, and public risk. The team builds an incident action plan for each operational period. It sets priorities, assigns divisions, organizes communications, identifies weather concerns, establishes medical and evacuation procedures, and coordinates with sheriffs, utilities, road departments, tribal governments, land agencies, and community leaders. White 24 teams are already committed in one geographic area. The next complex fire cannot simply create a new experienced command organization overnight. Personnel fatigue becomes part of the hazard. Wildland assignments involve long shifts, heat, smoke, rough terrain, heavy equipment, and rapidly changing conditions. Rest rules protect crews and aviation personnel from errors that become more likely when people are exhausted. And those rules also mean staffing cannot be stretched indefinitely by asking everyone to work longer. The same constraint applies to aircraft. Pilots have duty limits. Helicopters and tankers have maintenance schedules. And smoke, wind, terrain, and temporary flight restrictions can narrow the window when aviation is useful. At the national level, coordination becomes an exercise in timing. A resource may be available on paper but too far away to influence the next operational period. Another may arrive after a weather front has passed, when it is useful for containment but too late to stop the run that threatened a community. Preparedness Level 5 does not mean every request is denied. It means priorities must be sharper because the cost of sending a scarce resource to one incident is the delay it creates somewhere else. The wildfire crisis is not defined only by flame length or the size of the largest perimeter. It is defined by how many complex incidents demand the same scarce capabilities at the same time. One fire may need engines for structure protection, and another may need helicopters for inaccessible terrain. A third may require a national incident team because several counties, agencies, tribal lands, power lines, railroads, and evacuation zones are involved. The most important resource is sometimes not an aircraft. It is coordination. Any large incident can receive hundreds of personnel and still struggle if information, priorities, and logistics are not organized. Airspace must be managed so helicopters, drones, and air tankers do not conflict, and roads must remain open for evacuations while engines enter. Public warnings must reflect changing fire behavior without creating confusion. At Preparedness Level 5, national priorities decide where limited resources go first. The guiding questions include risk to life, threat to property and critical infrastructure, the expected effectiveness of additional resources, and whether a fire can be contained before conditions worsen, and this can create a painful reality. Not every remote acre can receive the same suppression effort. Some fires may be monitored or managed with fewer resources while crews concentrate on communities, evacuation routes, watersheds, power systems, and incidents capable of rapid expansion. That is not abandonment, it is triage across a national emergency system. The count of 87 Western fires, therefore, tells only the opening of the story. The active incident summary listed 141 incidents nationally because it included fires with varying status, complexes, and other significant incidents. 99 were classified as uncontained large fires. The Western geographic areas accounted for 87 of those 99 when the regional totals were added together. The Northwest alone accounted for 50. That concentration matters because neighboring incidents often experience the same weather window. An A front moving through Oregon, Washington, Idaho, and Montana can increase activity on many fires within hours. Aircraft grounded by wind in one area cannot simply be shifted to another area experiencing the same conditions. Smoke multiplies the reach of the crisis. Flames threaten communities near the perimeter. And smoke can travel hundreds of thousands of miles, affecting people who never see the fire itself. The finest particles, known as PM2.5, can penetrate deep into the lungs and are the pollutant of greatest health concern in wildfire smoke. And the smoke is not one uniform cloud. A rising fire column can inject particles high into the atmosphere, where stronger winds transport them long distances. Near the ground, smoke can settle into valleys overnight and lift as daytime heating mixes the air. One community may exceed hazardous air, while another nearby sees blue sky above smoke trapped lower in the terrain. NASA's July 26th image of Oregon showed long smoke plumes extending northeast from central and eastern fires. Air quality advisories were issued for parts of the state. National Weather Service pages later described wildfire smoke and poor air quality continuing across the Pacific Northwest and Rockies and extending into the plains. Smoke can also reduce visibility for aviation and ground crews. It can hide terrain, make aerial drops less effective, and prevent aircraft from operating safely. A fire can need more aviation support at the exact moment smoke makes that support unavailable. This is another operational feedback. More fire creates more smoke, and more smoke can reduce the tools available to fight the fire. The broader 2026 season was already running above recent averages. And by August 2nd, federal statistics listed more than 45,000 wildfires and about 5.3 million acres burned nationwide since the start of the year. That was 132% of the 10-year average number of fires and 142% of average acreage for the date. And those percentages do not mean every part of the country was experiencing a record season. They show that national demand entered August from an elevated starting point. And the current active fire acreage and year-to-date acreage are also different measures. Active acreage summarizes incidents still being tracked in the operational report. Year-to-date acreage includes fires that have already been contained or closed. Combining them would double count land and create a false total, and that distinction matters because wildfire numbers move constantly. Perimeters improve after infrared flights. Complexes combine several incidents. A fire can be contained and leave the uncontained count. New starts can replace it before the next morning report. The title is a snapshot, not a permanent statistic. In the next phase of the story depends on August weather. NIFC's seasonal outlook forecasts above normal, significant fire potential across much of the northwestward to the Pacific Northwest coast and northwest California, Wyoming, and Montana westward to the Pacific Northwest coast and northwest to the Pacific Northwest. In September, above normal potential is expected to persist across the northwest, much of the North Great Basin, and northeast California. And that is a forecast of potential, not a forecast of 87 specific fires continuing or a prediction that a town will burn. Significant fire potential combines expected weather, fuel dryness, climate patterns, and the likelihood that fires will require outside resources. A region can have above normal potential without experiencing a disaster if ignitions remain low and initial attack succeeds. The opposite is also possible. A brief wind event can make one fire exceptionally destructive, even during an otherwise normal month. Scientists and fire managers will watch several moving indicators. And the first is new ignition count, especially after dry lightning or wind events. The second is large fire growth because rapid expansion can force evacuations and require additional teams. And the third is containment progress. If crews secure perimeters during milder weather, resources can be released before the next critical period. The fourth is smoke and air quality, which can create a regional health emergency far beyond the flames. The fifth is resource availability itself. A reduction from level 5 would show that national demand and available capacity had moved back toward balance. Remaining at level 5 would mean the system was still operating with heavy commitments and emergency measures. And the long-term background adds pressure without providing a single cause for every flame. The Western fire environment has always included drought, lightning, wind, and large burns. Modern development has placed more homes, roads, power lines, and communities within fire-prone lands and communities within fire-prone landscapes, increasing the number of people and systems exposed when fire returns. And climate change contributes to longer periods of hot, dry fire weather in much of the West, but it does not identify the ignition source of a particular incident. In a lightning strike, equipment failure, power line, vehicle, campfire, or intentional act can start a fire. The resulting spread depends on the weather and fuel conditions present at that place and time. And fuel is also shaped by history. Decades of fire exclusion allowed dense vegetation and dead material to accumulate in some forests that evolved with more frequent, lower-intensity fire. Invasive annual grasses have created a different problem across parts of the Great Basin, filling spaces between shrubs with fast-drying fuel that can carry flames across large areas. There is no single treatment for all Western landscapes. Prescribed fire can reduce hazardous fuel under selected weather conditions. Mechanical thinning can remove smaller trees and brush near communities or in specific forest types. Grazing, invasive species control, defensible space, and building design can reduce risk in grasslands and developed areas. None of these measures makes a landscape fireproof, and they change fire behavior or improve the chance that crews can protect a community when conditions become severe. The same distinction applies to suppression. Putting out every fire as quickly as possible protects lives and property during dangerous weather. But some ecosystems need periodic fire. Managers must separate the emergent incident from the longer ecological question of how fire should function on the land, and that complexity is easy to lose when a map displays 87 fire symbols. Each icon represents a different ignition, fuel type, ownership pattern, management objective, and level of threat. The common crisis exists in the shared weather and response system, not in a claim that every acre should be treated exactly the same. It also explains why prevention messages intensify at high preparedness levels. One human-caused ignition that would normally receive a strong local response can become much harder to contain when nearby crews and aircraft are already assigned. Preventing a new start protects not only the place where it might occur, but the limited national capacity available for fires already burning. The honest boundary is clear. The American West is not one continuous inferno. The official count does not mean 87 cities are burning, and it does not mean every listed fire is displaying extreme behavior. The term large fire is an operational category, not a synonym for catastrophic, and yet minimizing the situation would be equally false. The West contained 87 uncontained large fires in the latest report. The West contained 87 uncontained large fires in the latest report. The Northwest held 50 of them, and nearly 28,000 people were assigned nationally, while international specialists and military firefighting aircraft had been mobilized. National preparedness stood at the maximum level, describing a system under real pressure. Picture the final scene inside a coordination center before sunrise. A wall-size map shows fires from California to Washington and east into Montana, Idaho, Nevada, Utah, Wyoming, Colorado, Arizona, and New Mexico. And some icons represent quiet perimeters. Others mark incidents that ran overnight, crossed a road, or triggered a new evacuation. A dispatcher receives an order for a helicopter, but another fire has requested the same type of aircraft. Weather forecasts show wind increasing after noon while a lightning area appears on tomorrow's map. Crews released from one incident are still hours away from the next assignment. Outside, most of the West is not in flames. Inside the system, almost every available move is connected. The next fire may begin as one spark in dry grass. And what makes it dangerous is that the people and machines needed to stop it may already be somewhere else.